So we've been talking about factoring for the past couple of days, and we are going to learn about a special case of factoring called a difference of perfect squares. Before we get into what that means, let's review our squares. So like 1 squared would mean 1 times 1, which is 1. 2 squared would be 2 times 2, which is 4. 3 squared is 3 times 3, and that's 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81, and 10 squared is 100. And these are going to come in very handy later. So when we're talking about the difference of perfect squares, difference in math means that we are subtracting. And perfect squares, we would say, is something that can be written as a number or something times itself. Something that is multiplied by itself. So all of these up here, 1, 4, 9, 16, 25, 181, 64, 49, and 36 are perfect squares because they can all be written as some number times itself. For example, 81 would be 9 squared. So 81 is a perfect square. So when we have a polynomial that's a binomial really, that's a difference of perfect squares, that means that there's a subtraction sign in the middle as we see here, and two things that are representative of something multiplied by itself. So a squared would be a times a, and b squared is b times b. And whenever you have a squared minus b squared, so something that looks like this, it's going to factor really nicely into a minus b times a plus b. And every time this will be true. So we're going to look at some examples down here. So number 1 says s squared minus 49. Well, s squared is s times s. 49 is 7 times 7. So this is a difference, a subtraction of two perfect squares, so s times s and 7 times 7. So this factors really nicely into s minus 7 and s plus 7. So notice my parentheses are identical. They both have s and 7. And those s's came from here. That's where the s's came from. And then my 7 came from these two numbers, my 7 times 7. So this factors really well into s minus 7 times s plus 7. So if I have t squared minus 81, well, t squared is t times t. 81 is 9 times 9. So this will factor into t minus 9 times t plus 9. And it does not matter if the plus is first or the minus is first. That information is not important. But what matters is that you have one of each. So number 3 is still a problem like this. It says 16 minus x squared. Well, 16 is 4 times 4, and x squared is x times x. So this will factor into 4 minus x times 4 plus x. I want you to notice that this time my number came first, the 4 was first, and the reason the 4 was first was because the 4 times 4 gave us our 16, and that was what came first in our problem. So for the second half of it, which was our x and our x, that's why x went second in the parentheses. So problem 4 is, again, while it doesn't necessarily appear to be, a difference of squares. And the reason this is a difference of perfect squares is because 4g squared is really 2g times 2g. Because 4 is 2 times 2, and g squared is g times g. And then the 25 is 5 times 5. So just like all the others, this will factor nicely into 2g plus 5 and 2g minus 5. So notice that my 2g's went first in my parentheses because that was the first part of my problem, and then my 5 went second because that was the second part of the problem. For 5 and 6, I'd like for you to pause the video and then try to work 5 and 6 out on your own to see if you can figure those two out, and then unpause the video to see if you got the solutions correct. So for problem 6, 36h squared was 6h times 6h. So notice I put a 6h in the first half of each parentheses. 121, that was a little hard to figure out, was 11 times 11. So that's where my two 11s came from. And notice one parentheses has a plus and one has a minus. So my answer was 6h plus 11 and 6h minus 11. Problem 6. 81 minus 49k squared became 9 plus 7k times 9 minus 7k, because 9 times 9 gave us our 81, so that's where these 9s came from. And the 7k's came because 7k times 7k is 49k squared. When I'm factoring, just the steps to remember, like for Algebra 1, just the basic factoring that we're going to do. First and foremost, always look for a GCF. Always look to see if you can divide all the terms in a problem by something. Number 2, figure out, is it a difference of perfect squares? That's what we just learned about. The difference of perfect squares problems are going to be in the form of a squared minus b squared. So it's something squared minus something else squared, and that will factor really nicely for us. And if that doesn't work, then we can use the AC method, which we've been using all along. I wanted to review a couple of problems with you. So I have problem 9 here that's on the back of your notes. It says 4x squared plus 12x plus 9. So first thing we're always going to look for is to see if I can divide 4, 12, and 9 by something, which I cannot. So my next thing is I need to draw my table. And on the left side is my product side, which is always a times c. Let me identify a, b, and c. Well, a is the number in front of x squared, b is the number in front of x, c is the number by itself. So for this left side, I'm going to multiply 4 times 9, which is going to give me 36. On the right side is my sum side, which is always b, and that is 12 in this case. I'm going to go ahead and put my plus signs in there just to denote that they are both positive. So I've got to look for, on the left side, two things that multiply to give me 36. Well, I've got a lot of stuff, and so I'm going to start with 1 and 36. They could both be positive, or they could both be negative. 2 and 18, again, they could both be positive or both be negative. 3 and 12, both positive or both negative. 4 times 9, or negative 4 times negative 9. And lastly, 6 times 6, or negative 6 times negative 6. On the right side over here, I need to add each of those. So I'm not going to write out what I'm doing. I'm just going to go ahead and add them. Well, 1 plus 36 is 37. Negative 1 plus negative 36 is negative 37. 2 and 18 is 20. Negative 2 and negative 18 is negative 20. 3 and 12 is 15. Negative 3 and 12 is negative 15. 4 and 9 is 13. Negative 4 and negative 9 is negative 13. 6 and 6 is 12. And negative 6 and negative 6 is negative 12. Remember, I'm looking for a set that when I add them together gave me positive 12. Well, that's going to work out to be 6 and 6. So 6 and 6 is my pair of numbers. So I'm going to rewrite this problem. Instead of being 4x squared plus 12x plus 9, it's going to be 4x squared plus 6x plus 6x plus 9. So I bring down the 4x squared, I bring down the 9, and I split the 12x. I rewrite the 12x as 6x plus 6x. So I'm going to look at the first two pieces, and I've got to figure out what they have in common. Well, 4x squared plus 6x, they're both divisible by 2, and they both have an x in there. So I'm going to factor out that 2x, and that leaves me with 2x plus 3. So if I divide this 4x squared by 2x, I get 2x. If I divide 6x by 2x, I get 3. You can also think of it as writing 4x squared is 2 times 2 and then 2x's. And 6x would be 2 times 3 times x. And notice if I'm looking for what they have in common, they both have a 2 and they both have an x. And that's where the 2x comes from. And then my leftover pieces here, my 2x and then my plus 3 is where this middle part comes from. So now I'm going to look at the second half. Well, I always bring down this sign, whatever this sign is, which is a plus sign. And then I've got to figure out what 6x and 9 have in common. Well, 6 and 9 are both divisible by 3. And if I divide 6x by 3, I'm left with 2x. If I divide 9 by 3, I'm left with 3. So I end up with 3 times 2x plus 3. If you're unsure of where that comes from, remember 6 is 2 times 3 times x, and then 9 is 3 times 3. So if I'm looking for what they have in common, well, they both have a 3 in them. I apologize. So I'm going to factor out that 3, and that's where the 3 comes from. And then my leftover pieces are 2x plus 3, and that's where the inside parentheses came from. So now looking at my entire problem, I want you to notice that we did it correctly. And the reason that we know we did it correctly is because both of my parentheses are 2x plus 3. So since they're both 2x plus 3, I can actually rewrite this as 2x plus 3 because that's what was in the parentheses. And then I can write it as 2x. The other half would also be 2x plus 3. And the reason that part is 2x plus 3 is because that was what was in front of the parentheses. So that's where the second 2x plus 3 comes from. Lastly, problem 10 says 16x squared minus 40x plus 25. So first I need to look to see if I can divide 16, 40, and 25 by something. I cannot. So I'm going to make my t-chart. On the left side is my product side, which is always A times C. And 16 times 25 is going to give us a positive 400. On the right side is my sum side, which is always B, which in this case is negative 40. I'm going to be honest, it's going to take you a little bit to find this one because 400 is such a big number and it has so many factors. So I'm going to help you out on this one, and I'm going to tell you that it's negative 20 times negative 20. The reason I know this is because a negative times a negative gives me a positive. 20 times 20 is 400. And then if I were to add negative 20 plus negative 20, I would actually get negative 40, which is what I'm looking for. So I'm going to rewrite this problem. Instead of 16x squared minus 40x, it's going to be 16x squared minus 20x plus 25. And I've got to look at each half of this and see what they have in common. So starting with the left side, well, 16x squared and 20x squared, 16 and 20 are both divisible by 4, so I'm going to be able to take a 4 out of that. And x squared and x, they both have an x in there. So if I divide 16x squared by 4x, then I am left with 4x. And then negative 20x divided by 4x is going to leave me with negative 5. I'm going to move the other half over, and I always bring down whatever this sign is, which is a minus sign, and I've got to figure out what 20 and x and 25 have in common. Well, I can divide both 20 and 25 by 5. That's their greatest common factor. So if I divide 20x by 5, I'm left with 4x, and notice that I'm really dividing a negative 20x by a negative 5, and a negative divided by a negative is a positive. That's why we don't put a sign here. Then I have a positive 25 that I'm dividing by a negative 25. 25 divided by negative 5 is negative 5. We know we did this correctly because if we look at our parentheses, they both say 4x minus 5. So that means I can write my final answer, which is going to be 4x minus 5 times 4x minus 5. Well, the first 4x minus 5 came from what was in the parentheses because that was the same in both of them. The second 4x minus 5 came because that was what was in front of the parentheses. So this would be my final answer.